Hello guys, good day to all of you and welcome to this video discussion. My name is Teacher G and our topic for today is about logic circuit. Before we start, let me ask you first if you have watched movies that is something like you think it is very advanced in technology. Something like, for example, when an actor will enter in a certain room and the actor claps his hand, then automatic the lights will turn on. When he clap his hands two times or three times again, then the music will turn on. When he clap his hands one time, let us say the air condition will turn on. Or when he clap his hands several times, everything will turn off. Something like that. And you think, wow, it's so advanced. Actually, we can actually do that one. So those are through the use of different sensors and through logic circuits. So today's topic is all about the logic circuit. So let us start first from the basics. So when you say logic circuit, it is an electronic circuit used in computers to perform logical operations. So when you give an input, say for example a clap or let us say a sneeze, anything that you want with respect to the sensor, then the sensor will give an output. Okay. So say for example, uh, when someone approaches your door, when the sensor senses that there is a motion in front of your door, then it will give an output. Say, for example, it will set the alarm, or let us say it will turn on the lights in the perimeter of your house, something like that. So that is through the use of the logic circuit. Another example of a logic circuit is if you have tried riding in an elevator by choosing a number which floor to go. When someone enters in a elevator, then presses, say for example, floor number 5, then another one will enter floor number 4, and the other one will enter floor number 10. So why do you think that that elevator will stop at that certain floor? That is through the help of a logic circuit. So in a logic circuit, let us talk first the six basic circuits. Okay, so we have the AND gate, the NOT gate, the OR gate, the NAND gate, the NOR gate, and the XOR gate or the exclusive OR gates. So those are the six basic circuits that we are going to discuss today. So when we say logic gates, logic gate is an idealized model of computation or physical electronic device that implements a Boolean function. So a logical operation is performed. So based on the binary inputs. And it will give a single binary output. This means that there are one or more inputs, but it produces one output. So what I am talking to is this one. Those logic gates mentioned looks the same. So it looks the same an IC, but it has different pin numbers and orientations. So through the help of these ICs, one of the components used in a logic circuit is the IC. So it has a big function in your logic circuit. Okay. So what is AND gate looks like? When you say AND gate, It looks like this one. What is OR gate? It looks like this one. What is NOR gate? It looks like this one. Na? Okay, later on we will discuss what is inside of the IC. Okay class, let us start with AND gate. So an AND gate, ang symbol niyan is parang letter D. Sorry, like this one. Okay. So this is your input and this is your output. So you can have multiple inputs but you have only one output. So that is output F. Okay? So say for example you have an input A and input B. So your output here in an AND gate, it uses a dot sign, no? A dot sign to indicate an AND gate. So your output must be A dot B. So meaning it is a multiplication. Again, remember AND gate uses a dot symbol to indicate that it is an AND gate. So if you have an input A and B, so the output is A dot B. So in an AND gate, it says that your output is high when both inputs is high. Ano ba yung high? High means logic 1. When low, that is logic 0. Okay? So, let us use a truth table for this one. Ano ba yung truth table, sir? A truth table, it is used to, the truth table will show all possible inputs and output combination. So, say for example, you have here the input. What are our inputs? We have A and B. So, A, B. So, what is our output? The output F natin. What is our output F? That is A dot B. So, say for example, your input is 0, 0. Ano kaya ang magiging output natin? So, our output will be 0. Why? Because sabi dito, magbibigay lamang siya ng output na high or 1 if all of its inputs are high. So in this case, our inputs are 0, 0, meaning low, low. So it is a logic that if it is not high, then it is a low. Okay? Next, what if our input is the other one is 0 and the other one is 1. 0, 1. What will be our output? So our output will be 0 because according to AND gate, your output will be high or 1 if all inputs are high. But in this case, we have one low and one high. So the logic is the output will be low. What if this one? Your input A is 0, but your input B is, your input A is 1, but your input B is 0. So your output will be still 0. But if both inputs A and B are high, so that is the time it will give an output of high. Okay. This is now your truth table. It shows all the possible combinations of inputs and output. Okay? So, since ang symbol ng circuit natin is parang letter D, okay? So, meaning, if your A is equal to 1 and your B is equal to 1, so therefore, your output here, F, which is A dot B is equal to 1. Okay? Is equal to 1. That is AND gate. Again, remember, AND gate, when you encounter an expression like this one, a dot b, x dot y, as long as there is a dot, that represents an AND gate. And the symbol for that one is like this one, something like parang letter D. There are inputs and only one output. And it will give an output of high if all inputs are high. So our next logic gate is the OR gate. So sa OR gate, we use a plus sign to indicate an OR gate. So the symbol for OR gate is something like this one. Okay, browse lang tayo sa internet. Merong makikita nyo kung ano ang exact na itsura ng OR gate. So an OR gate, still, dito yung input natin. And this is our output. Output F. So, if you have an input A and input B, then your output will be A plus B. So again, if you encounter an expression that uses a plus sign, this means that expression is an OR gate. So, isipin nyo agad, ito ang symbol ng OR gate. According to OR gate is magbibigay lamang siya ng output. Again, output is high. Kung any of the inputs is high. Okay? Remember, again, high is logic 1 and low is logic 0. So, through the help of the truth table, okay, we have the input here, we have the output here. So, say for example, you have input A and input B, and we have the output A plus B. So, say for example, 0, 0, 0, 1, 1, 0, 1, 1. So, these are the possible input combinations natin. Ang combinations ng input natin, pwedeng 0, 0, maaring 0, 1, maaring 1, 0, maaring 1, 1. So, if your inputs are 0, 0 or low, low, what will be your output? Remember, ito ang sabi niya. Magbibigay lamang siya ng output na 1 or high kung any of its inputs are high. So, kung parehong low, meaning the output is low. If 0, 1, so meron bang 1? Meron. Sabi kasi dito, any of the inputs. This is input, this is input. So any of the two is high, like this one, 0, 1, there is high, that is the time nagbibigay siya ng output na high. Okay. If 1, 0, sir, there is one high of the inputs and the other one is low. So still, the output is high. Sir, now, what if 1, 1? Of course, any of the inputs or pwedeng both. So 1, 1, of course, that is 1. So therefore, again, the symbol for our OR gate is, say for example, A is logic 1 and B is logic 1. So your output here is logic 1. If A natin dito is 0 and B is 1, logic 1. If ito ay 1 at ito ay 0, that is 1. Pero kung ito ay 0 at 0, so this is 0. That is the logic of OR gate. Okay, so the next logic gate is the so-called the NOT gate. Okay, the NOT gate. Ang NOT gate is simply, the other term for NOT gate is inverter. Okay? So when we say NOT gate, the symbol for this one is like this one. This is the input, one output only. So, ang sabi ni Nand Gate that si Nand Gate magbibigay lamang ng output the negated value or the inverted value. So, say for example, if mag-input siya ng A, or ito na lang muna. If mag-input siya ng 1, say for example, so anong kabaliktaran ng 1 in a logic circuit? Sa logic circuit kasi, dalawa lang ang numbers na makikita natin because it is in terms of binary. So, if it is not 1, then that is 0. Only 0 and 1 ang makikita natin. Meaning on or off. So, say for example, if ang input mo is 1, so ang output is the inverted value. So, that is 0. Okay, klaro. If it is not 1, then therefore it is 0. That is Nand Gate. If it is not 0, then that is 1. So, kung ito ay babae, so ang kanyang output is lalaki. If ito ay lalaki, then therefore the output is babae. That is a Nand Gate. So, it gives an inverted value of its input. So, in this case, ito yung symbol niya ha. If ang input mo is A, so ang inverted value niyan is A bar. It's like 1. Pag may bar, meaning 0. Okay, again. Kung may bar, this means it is 0. Pag wala, that is 1. Kung ang input niya is A, idinaan natin sa Nand Gate. So, ang output niya is A bar. Kung ang input niya is A bar, so ang kalalabasan niyan, that is A. Kung pinasok mo si 0, ang labas niyan is 1. That is a Nand Gate, or otherwise known as the inverter. It will produce an output, the negated or the inverted version of its input. Okay? So again, ang tawag dito A bar. The next logic gate is the so-called Xor Gate. Okay, Xor Gate. The symbol for an Xor Gate is something like this one. Parang or, pareho tulad nung kanina. Then, mayroong isang ganyan at meron tayong inputs. A and B. Input natin yan. That is your input. And this is your output. F. So, in the XOR gate, the symbol used here is an encircled plus sign. So, in an XOR gate, the output will be A plus encircled B. Okay. If you can encounter an expression like that, so automatically that is an XOR gate. The symbol for that XOR gate is this one. Anong sabi ni XOR gate? According to XOR gate, magbibigay lamang siya ng output. Okay. The output is high. Okay. If any of inputs is high but not both. Again, an XOR gate uses an encircled plus sign to indicate an XOR. The symbol is this one. So if you have inputs A and B, the output will be A encircled plus B. So, according to the definition, this is your input. Let us use the truth table here. This is your A and B. inputs, and this is your A output. 0, 0, 0, 1, 1, 0, 1, 1. Okay. So sabi dito, magbibigay lamang ang XOR gate ng output na 1, high or 1, if any of its input is high but not both. Oh, what does it mean? So let us trace it in the truth table. If inputs natin ay 0, 0 or low, low, what will be your answer? That is 0. Okay? Kasi hindi nag-mention dito na ang low at saka low magbibigay ng high. 0, 1. Inputs 0, 1. Any of the inputs is high. So there is 1 high. So magbibigay siya ng logic 1. Dito, 1, 0. May isang input na high, logic 1, according to this. Then, pag 1, 1, sabi dito, not both. No? Magbibigay lang siya ng 1 kung any of its inputs is high, but not both. But this one, input A and B is 1, 1, meaning A and B are both logic 1 or high. So, what will be the answer? The answer is 0. Okay? So therefore, when your A is equal to 1 and B is equal to 0, okay. This is the symbol for your XOR gate, na? Lakihan natin ng konti. This one. Okay. If 1, 0, so your output is equal to 1. If this is 0 and this is 1, your output is 1. If this is 1 and this is 1, so the output is 0. Okay? Okay, next is the Nand Gate. Okay, the Nand Gate. So, ang Nand Gate is a combination of a NOT gate, the NOT gate, and an AND gate. So, kanina, ang symbol ng NOT gate natin is ganyan. Ang AND gate natin is ganyan. So, now, the NAND gate symbol is ganito, kinombine. So, this one, may input tayo dito, A, B. Tapos, merong bilog dito, kinuha natin galing sa NOT gate. This is your NOT, this is your AND. So, kinuha natin yung bilog niya, at dito inilabas. So, kung ang NOT gate, mag-output tayo ng A bar, ang NAND gate is A.B. So, dito, ang magiging output natin is A.B, then lahat bar. A.B bar. If you can encounter this one, meaning it is a NAND gate. Okay. So, anong sabi ni NAND gate? Ang NAND gate, magbibigay lamang ng output na high if ang any input is low. Oh, iba na naman ang sa NAND gate. Sorry. Through the help of this truth table, we have input A, input B, we have an output. Okay? So, this is our input. This is our output. So, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So, sabi dito ni NAND gate that magbibigay lamang siya ng logic 1 or high. Logic 1. Kung any, kahit isa sa mga input nito ay low or logic 0. So in this case, 0, 0. Ang inputs ba natin ay low or high? Of course, it is low. So sabi dito, any sa kanyang input ay low. Magbibigay siya ng 1. So 0, 0, meaning that is 1. Okay? 0, 1. Meron bang low sa input? Meron. This A. 0. That is low. So, ang output is 1. This one, 1, 0. May low ba? Meron. So, that is 1. Dito sa 1, 1, may low ba? Wala. So, meaning, if walang low, therefore, your output is 0. Okay. So, kung i-trace natin, okay, if this is your A and B inputs and this is your output, if A is 0, B is 0, so your output is 1. If A is 0 and B is 1, that is logic 1. If this is 1, this is 0, logic 1. But if this is 1 and 1, then the output is 0. And that is Nand Gate. Okay. So our next item is the NOR Gate. Okay. Ang NOR Gate is a combination of a NOT and an AND gate. So again, ang NOT gate natin is ganyan. At saka, I'm sorry, this is not a combination of a NOT and an OR rather. OR. So ang OR natin is ganito yung symbol natin kanina, di ba? Okay. Input A bar, input A and B, we have the A plus B. Excuse me. So the symbol for NOR gate is this one. So we are taking this symbol from OR gate and adding the NOT gate. Okay. That is your symbol for NOR gate. So, if your input A and B, so your output is taking this one, A plus B plus the bar of the NOT gate. So that is now your what they call NOR gate. Okay. So, anong sabi ni NOR Gate? Si NOR Gate, magbibigay lamang siya ng output. Iba na naman kay NOR Gate. The output is low or 0. Okay? If any of the inputs is high or logic 1. So, truth table, input, output. So, we have input A, input B. So, output A plus B bar. So, possible combination, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So, sabi dito, magbibigay siya ng output na 0 kung ang kanyang inputs, any, kahit isa sa mga input ay high or 1. Dito ba may input na high? Wala. So therefore, anong sagot dito? Logic 1. Saka lamang siya magsi-0 kung mayroong 1. But in this case, 0, 0, 1. 0, 1. Meron bang high ang input? Meron. This one. So what is the output? 0. 1, 0. Meron ba tayong input na high? Meron. So what is the output? Low. Next, meron bang input na high? Meron, dalawa. So what is the output? 0. That is now the NOR gate. So, i-trace natin, balik ng symbol. Kayo nang bahala sa symbol ha. Hanapin nyo na lang sa Google. If your input A and B, then this is the output. So again, if your input is 0 and 0, So the output is 1. If this is 1, this is 0, the output is 0. If this is 0, this is 1, the output is 0. If this is 1 and this is 1, then the output is 0. Okay guys, so yun po ang functions and outputs of the logic gates, the six basic logic gates, the AND gate, OR gate, NOR gate, Nand gate, Xor gate, no? So after understanding the different types of logic gates, so let us now proceed to the simplification, no? Mag-simplify tayo until such time makaabot tayo sa what we call paano gawin ang isang circuit. Okay. Based sa module na binigay ko, so you already have there the postulates, na? So please make sure to have a copy of the postulates and theorems in your notebook for your reference in the next activities. Okay. Okay, so based on the postulates na binigay ko, so these are the equivalents, na? So our postulates, when you say 1 bar, okay, focus natin ng konti. Okay, medyo okay. Based on the postulates na binigay ko, double check your copy. So tingnan niyo yung kopya niyo. So these are the postulates. 1 bar is equal to 0, 0 bar is equal to 1. 0, okay, 0.0 or 0 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1. Sa addition naman tayo, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 1. Always remember that one. So A times A is equal to A. A times 1 is A. A times 0 is 0. A times A bar is 0. This one, this is a so-called A double bar. Wala to, wala. This one. Ignore. Okay. A double bar is equal to A. Okay. Next, A plus A is A. A plus 1 is 1. A plus 0 is A. A plus A bar is 1. Always remember these postulates kasi very useful ito in the next activities. Make sure you have a copy of these postulates in your notebook. Okay. Then we also have here the theorems. Okay. The theorems. So when you say AB, so that is equivalent to B times A. So when you say A plus B, pwede siya magiging B plus A. So when you have here A times BC, so kung i-multiply natin yan, pwede rin A times B times C. Okay, like this one. Dito naman A plus the quantity of B plus C, then the answer is pwedeng the quantity of A plus B plus C. This one, ito. A plus B quantity of A plus B times the quantity of A plus C. So ang theorem natin dyan is magiging A plus BC. AB plus AC is equivalent to A times quantity of B plus C. A plus AB is equal to A. A plus quantity A plus B is A. A plus A bar B is equal to A plus B. And A times quantity of A bar plus B is AB. We also have here the De Morgan's theorem. So, A plus B all over bar na siya, ha? A plus B bar. So, is equivalent to ang plus magiging multiplication. So, dito buo. The A plus B, okay, look at this. The A plus B, ang bar niya is from A to B. So, equivalent siya kung i-solve natin yan. So, ang plus magiging multiplication or the dot. Then, individually, meron silang tigi isang bar. Dito naman, A dot bar or A times B bar. So, ang kabaliktaran naman, ang dot or ang multiplication magiging addition. Okay, let us have an example. So, let us say you're going to prove the following. Say, for example, A plus AB. Let us prove that A plus AB is equal to A. So we need to simplify this expression to get an answer of A. So A plus AB, let us factor it out. What is common between the two terms? So the common is letter A. Get natin yan? Kuhanin natin ang letter A. So, ano ang value na pwede nating i-multiply sa A dito para makakuha tayo ng value na A? So, A times 1 is A plus. Ano ang i-multiply natin sa A para makakuha tayo ng AB? So, lagay natin is B. A times 1 is A. A times B, AB. Na? So, dapat equal to A daw. So, as you can see, this 1 plus B, kung titingnan natin ang postulate, ang 1 plus B, it is the same as this one. A plus 1 or 1 plus A, or pwedeng B plus 1 or 1 plus B. It is the same as that one. So 1 plus B or 1 plus A is equal to 1. So 1 plus B is magiging, that is 1. So therefore, A times 1 is equal to A. Kung titingnan natin ang A times 1, or it is the same as A dot 1, okay? Sa postulate natin, ang A times 1, this one, A times 1 is equal to A. So therefore, A times 1 is A. So, na-prove natin that A plus B is equal to A. So, A plus B, kung i-simplify natin yan, it will give a value of A. Okay, next example. Let us prove that, example number 2, that A plus A bar B is equal to A plus B. So, in this case, we're going to simplify these terms. So, the A, it can be simplified as, let us find a factor for this one. So, pwede tayong gagawa na mag-add ng expression that is equal to 1. So, say for example, let us multiply 1 plus B, for example. Alam naman natin that ang 1 plus B natin is 1. Tapos, A times 1 is A. Okay? So here, it is the same as ang A can be rewritten as A times 1 plus B. Because this is equivalent to 1. 1 times A is A. No? Pwede nating i-rewrite ng ganyan. Then, bring down natin plus A bar B is equal to A plus B. So, this one, pwede nating i-multiply ito dito. A times 1 is A. A times AB is AB. Okay? Plus A bar B equals to A plus B. In this case, meron na tayong first, second, and third term. So, let us choose two terms na merong common na pwede nating i-eliminate. So, in this case, let us try to eliminate A at saka A bar. Bakit? So, for example, A, this one, plus. What is common between these two terms? The common is B, right? B ang common. Kasi ito, A, itong isa, A bar. So, the common is B times. In order to get AB, so multiply B by A plus. In order to get A bar B, so we need to multiply B to A bar. So, equal to A plus B. So, looking back to our postulate, if we look at in our postulates, so A plus A bar is equal to 1. So therefore, A plus A bar is equal to 1. Then, B times 1 is B. Okay, that is the answer now. So, that is equal to A plus B. Okay, it is now proven that A plus A bar B is equal to A plus B. So, it is very important that you have a copy of the postulates and the theorem. Okay? So, let us proceed to the next example. Okay, for the third example, let us prove that A times the quantity of A plus B is equal to A. Okay, so let us simplify this term. So maraming paraan. Pwede mong i-factor, pwede mo siyang i-multiply as long as you get the right answer. So, A times A, that is A. Okay. A times B, that is B equal to A. So, dito, alam naman natin that A is the same as A times A. So, A times A, kung titingnan natin ang postulate, ang result niyan is A plus AB is equal to A. Next, this one, it can be simplified. What is common? Common is A. What value what value ang i-multiply sa A to get the value of A? 1. What value to be multiplied by A to get AB? That is 1 plus that is B equal to A. And looking back at our postulate, 1 plus B is the same as 1 plus A or A plus 1. Pareho lang yon. That will give us the value 1. So, A times 1 is equal to A. Therefore, A times A plus B is equal to A. So, it is true. Next, number 4. Let us prove that, for example, A plus B times A plus B bar is equal to A. Okay. So, let us apply the FOIL method. The FOIL method. The first term, this is our first term. Then, the last terms, outer terms, the out, both sides, that is the out. Then, the inner, and the last. Okay? So, let us rewrite this one. A plus B bar is equal to A. So, A times A will give us A first plus last. A times B bar, that gives us B bar plus the inner. B plus A, that gives us B. And last one is the last terms, B plus B bar, that is B bar. Okay. Let us rewrite this one. AA plus AB bar plus AB plus B bar. So, i-prove natin na that is equal to A. Okay. So, this term, AA, tingnan natin ulit ang postulate. A times A, that is A. Plus AB bar plus AB plus. Ano ba yung B times B bar? So, let us check the postulate. So, according to the postulate, tingnan nyo na lang ang postulate ninyo. So, B times B bar is the same as A times A bar. And that will give us the value of this one magiging 0. Okay. So, we have first term, second, third, and fourth term. So, here, we can eliminate second term and third term. A plus. So, what is common? Again, the common is A times value to multiply A to get AB bar. So, we have the B bar plus value to get AB. So, A times B, that is AB, plus 0. Okay. So, alam naman natin that A plus B bar, B bar plus B, tingnan natin ang postulate, that is 1. So, magiging result, A plus A times 1 plus 0 is equal to A. A plus A times 1, A plus 0 is equal to A. A plus A plus 0 equals to A. Then A plus 0, A is equal to A. So, we have proven that quantity A plus B times quantity A plus B bar is equal to A. Okay, very good. So, what is the purpose kung bakit natin sinimplify ang expression natin? Kasi, if hindi natin i-simplify, because those expressions na binigay ko sa inyo, di ba nakita natin kanina sa Nand Gate, Xor Gate, di ba may kanya-kanya siyang expressions. Kung Nand Gate, that is A times B. Pag Xor Gate, that is A plus B. Di ba? Tapos pag NOT gate, it can be A bar. Pwede ring A double bar, no? So, ang purpose kung bakit natin i-simplify, kasi if hindi natin i-simplify ang expression, ang mangyayari is napakaraming electronic components ang gagamitin natin sa pag-build natin sa ating circuit. Tapos, the more components na gagamitin, the more money it costs. Kasi bawat component ay binibili po yan. Okay? So, let us have one more example. Let us assume another value. Okay. Okay, let us try to simplify this expression. Given x plus y plus x bar y plus xy plus x bar y bar. Kung ito kasi ang gagamitin natin, kung idiretso natin to, alam naman natin recently that pag gumamit tayo ng plus sign, that is Xor Gate. Pag gumamit tayo ng multiplication, that is AND Gate. Pag multiplication, that is AND Gate. Pag multiplication, that is also AND Gate. Tama? Ngayon, kung ito at saka ito, in between is a plus. That is Xor Gate. So meaning from this OR to this OR, that is Xor Gate. Tama? Tapos, ito at saka ito, in between, plus. That is an OR Gate. Tama? Then, in between ito, this one and this one, we have here the plus sign. That is also an OR OR gate. Tama? Okay. Then kung titingnan mo dito, X bar. This is a bar. Meaning that is a NOT gate. Okay, that is NOT. This is also a NOT gate. And this is also a NOT gate. Okay. Now, kung bibilangin natin, ilang electronic components or ilang logic gates ang kakailanganin natin? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we need 10 logic gates. So, 10 logic gates. So, what are those gates? So, we have the OR gate. Ilan ang OR gate na kakailanganin? Isa, 1, 2, 3, 4. So, we have 4 OR gates. How about AND gates? We need 1, 2, 3. 3. And the NOT gate, we need 1, 2, 3. Okay. So, all in all, we need 10 logic gates. If the expression is not simplified, no? Kapag hindi simplified, ang mangyayari is gagamit tayo ng 4 na OR gate, 3 AND gate, at 3 NOT gate. So, all in all, 10 logic gates. But let us try to simplify. Okay. We have here x plus y. Balik natin na. Plus x bar y plus xy plus x bar y bar. So, dito, we have ilang terms? 1, 2, 3, 4, 5 terms. So, it's up to you to choose which term ang pwede nating i-eliminate. So, in this example, let us say, ito pwedeng silang hindi po pwede. Walang common sa kanila. Ito at saka ito may common. The common is x bar. Pwede rin ito at saka ito, ang common is y. So let us try this one. So we have x plus y plus. So what is common between the two terms? Y. Okay, this is y. Then anong natira? X bar plus, ang kabila is x. Then, x bar, y bar. So, let us simplify. Plus. Alam naman natin that x bar plus x. So, looking at your postulates. So, again, importante ang postulate. Make sure to have a copy in your notebook. X bar plus x is the same as a bar plus a. That is 1 plus x y bar bar. So, y times 1 is y. So, x plus y plus x bar y bar. Then, y plus y. Open your postulate again. Y plus y is y. Okay. X bar, y bar. Do you think we can still simplify this one? Pwede pa. Pero, pwedeng hanggang dito lang tayo as long as ma-simplify, minimize natin ang paggamit ng components. So, in this case, ano na lang ang components na kakailanganin natin? X and Y, that is OR gate. Bar to bar. This is bar. So, dito, that is AND gate. The AND gate. Then, dalawang NOT gate. Dalawang NOT gates kasi X bar, Y bar. Tapos, in between ito, the plus sign. In between yan, we have an OR gate. So, this time, ilan na lang? Dalawang OR gate, dalawang NOT gate, at isang AND gate. So, from 10 down to 5. See? Can you see the difference now? So again, it is important for you to simplify the expression in order to minimize the number of electronic components to be used in the circuit, and of course, to minimize the cost of your components. So I hope that you learned something from this topic. I know that this topic is new to you, and since it involves a Boolean algebra, so I am hoping that all of you have the basic background, the foundation of algebra. No? For the SSP students, it is quite difficult for you sa grade 9, but you need to undergo in this subject. Okay? And for the grade 10, I believe that you already have your algebra. So I guess it is easy for you. So all you need to do is to understand, you need to secure a copy of the postulates and the theorem so that you can answer or you can simplify the expression very well. Okay, so much for today. See you in the next video for the next lesson. Okay, bye-bye. This is Teacher G. Bye-bye.